Space, the final frontier. Come with us as we explore and unravel the mysteries of what lies beyond our planet Earth. Strap yourself in. Get your spacesuits ready as we prepare for takeoff in T-minus 5, 4, 3, 2, 1. Welcome to Inside Outer Space. Solar System. Now let's talk about the solar system. The Sun, our planet, our moon, the other planets and even their moons. They all make up the solar system. The solar system is a gravity-bound system that is comprised of the Sun and the objects that orbit it, hence the name. Because of the Sun's large mass, it exerts gravity or the force that attracts objects. This force keeps the planets and other objects, such as asteroids and dust, to keep a steady orbit or a path around the Sun. This movement around the Sun, coupled by the rotation of the planets in orbit, is what causes night and day, as well as the changing of the seasons. One whole rotation for planets is called a day, while one whole cycle around the Sun is known as a year. And for the Earth, that's 365.25 days. Other planets have varying distances around the Sun. Therefore, a year for these planets vary according to distance. So one might ask how the solar system began. Well, this is one of the questions that scientists have been trying to answer for years. There is of course a lot of interest in this topic because knowing about the origins of the solar system can help scientists better understand the origins of our own planet Earth, and subsequently how life originated here as well. Here's what we have so far. Scientists believe that the formation of the solar system took billions of years in the making. In the beginning, the solar system started from a giant cloud of dust and gas. As the clouds and dust grew more massive, it began to collapse on the weight of its own gravity. Because of its own gravity, this mass started to move in a giant circle, spinning faster and faster as it collects more dust and gas. And then a star started to form. It grew as it sucked in more dust and gas, eventually igniting and turning into what we now call the Sun. The Sun grew and began to blow solar winds, which pushed some of the remaining gas and dust outward. These gas and dust debris eventually formed into planets and moons. Planets closer to the Sun had the solar winds blow off more of the excess debris, making them smaller than the planets which are farther away from the Sun. There are 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. But there are also hundreds of smaller bodies, such as moons, minor planets, and asteroids, which are also kept in orbit by the Sun, and therefore are as much a part of the solar system as the planets. As for humans, well, we have been sending satellites and probes for decades now, since the 1950s. And we are still barely scratching the surface of planets that are beyond our own. Satellites. Satellites are the objects circling around a planet or a star. They come in many different forms and sizes, and some objects most of us think are not satellites actually are satellites too. The Earth, for instance, is a satellite because it orbits around the Sun, a yellow dwarf star. The other planets are also satellites because they also revolve around the Sun, and each planet, except for Mercury and Venus, have their own satellites as well, their moons. The Earth only has one, but the other planets have as many as 60. But the planets and their moons are what we call natural satellites. Those things we see seemingly floating in space are all man-made, or what we call artificial satellites. Artificial satellites are going to be the focus here because they do more than just float in space. The first man-made satellite in space was Sputnik 1, launched by the Soviet Union in 1957. The following year, the US launched its first satellite, the Explorer 1. Earth's first satellite photo was taken in 1959 by the US Explorer 6. Launching satellites have changed how people perceive the Earth and the outer space. Artificial satellites provide a bird's eye view that allow them to gather more useful data at once than telescopes or merely studying on the ground, which is why there are thousands of satellites in space, mostly stationed around Earth, to take pictures that could help predict weather and track incoming storms and hurricanes. Some satellites are sent to observe the Sun, other planets, and other objects that exist beyond the solar system. It's because of satellites that we know the Earth is mostly blue, with huge green and brown pieces on its surface and swirling white gases all around it. We learned the existence of Saturn's many rings or Jupiter's great red spot, all because of satellites. Through satellites, we can also be warned of approaching meteors that could crash into Earth or be more aware of dangerous sun rays. Many satellites are sent to orbit different planets, stars, and other celestial objects for further studies. Satellites also play a big part in communications. TV, telephone, and internet signals wouldn't have reached and connected people from longer distances if there were no satellites. Because before, signals were blocked by mountains and tall buildings, and telephone wires over long distances were hard and expensive to set up. Now, signals are just being sent upwards, and satellites send them back down to wherever the supposed recipients are. Satellites have different models and designs, but a lot of them have at least two parts in common: an antenna and a power source. The antenna delivers and acquires information, usually to and from the Earth. The power source could either be a battery or a solar panel. But wait, if they are not really celestial objects, then how do they get into space? Well, satellites are launched into space by rockets. The acceleration of the satellite due to the rocket launch decreases due to the pull of the Earth's gravity. Each satellite sent out to space orbits Earth at different distances, speeds, and paths. There are two common orbits: geostationary, which travels to a west to east motion, much like how the Earth rotates. That's why satellites in this path look like they don't move at all. The other orbit is polar, which travels to a north to south motion. It's necessary that all satellites are on different distances, speeds, and paths to avoid collision with other satellites. But this prevention gets increasingly difficult if more satellites are launched into space. Earth, the third planet from the Sun, coming in with a diameter of 12,756 kilometers, or 7,926 miles, and a mass of 5.97 times 10 to the 24th power kilogram, or 1.3 times 10 to the 25th power pounds, with one moon, and an orbit period of 365.24 days, with a varying surface temperature of -88 to 58 degrees Celsius, or -126 to 136 degrees Fahrenheit. It's the planet we call home, along with 7 billion other people. Welcome to Earth. The Earth is the only planet in the universe that does not have a Roman or Greek god's name. Its name comes from the old words like Eorde, Gaia, and Terra, which means world. The Earth's atmosphere is 21% oxygen, or the stuff that humans need to breathe. It remains to be the only planet which has 2/3 of its surface covered in liquid, or the water that makes up the Earth's oceans. This planet is also covered in solid rock plates that float on a hotter inner layer of molten rock. This is why there is volcanic and seismic activity in the Earth. The Earth has a tilt in its axis. This makes seasons throughout the year possible. The tilt makes some regions of the Earth receive less sunlight and warmth, thus directly causing regions in the northern and southern hemisphere to experience winter and other seasons. Telescopes. Before there were satellites, a long metal tube with mirrors and lenses is what we use to look at celestial bodies. A telescope. Telescopes go way back as far as the 17th century, when a patent of the first telescope was submitted by Hans Lippershey to the government in Netherlands. Although the actual inventor was unknown, the first version of the telescope was composed of a convex objective lens and a concave eyepiece. Galileo heard about this patent and decided to build his own version. Galileo proceeded to be the first person to point a telescope skyward, and he was able to make out mountains and craters on the moon's surface, despite the telescope being small and the images too fuzzy. Galileo's telescope was also the first one to observe the Milky Way galaxy. Of course, during that time, he hasn't realized that yet. Using his own version of the telescope, Galileo was also able to identify Jupiter's 4 biggest moons, collectively known as the Galilean moons: Ganymede, Io, Callisto, and Europa. The technology of telescopes has greatly improved after Galileo and Newton's time. The telescopes are now bigger and more complex. This enables astronomers to discover faint stars and calculate stellar distances. In the 19th century, a new instrument called the spectroscope became popular. During this time, astronomers were already able to identify the chemical composition and motions of heavenly bodies. From there, telescopes became bigger and bigger and went on to become specialized instruments that could look into further distances in space and time. But of course, despite having the most advanced telescope mounted on the ground, it is not invincible from the atmosphere's visual tricks, which is why in the 1940s, astronomer Lyman Spitzer dreamed of having an observatory in space, positioned above Earth's atmosphere so that observations would be more accurate and the view would be sharper. So, in the 1970s, NASA and the European Space Agency, or ESA, collaborated to design and build what is now called Hubble Space Telescope. In 1990, 5 astronauts boarded the Space Shuttle. The Hubble Space Telescope was deployed in an orbit around 300 miles or 482.8 kilometers above the Earth's surface. The images that the Hubble delivered was more than expected. This space telescope symbolized the accomplishment of a 50-year-old dream and decades of hard work and collective effort of scientists, engineers, contractors, and institutions around the world. Of course, today, space and aeronautics agencies also now heavily rely on satellites because you can also launch them into space and send them to greater distances and get a closer look on stars, planets, and other objects. However, telescopes are still widely used for space and aeronautic studies. If you're very much interested in space, but you're not a part of NASA or any space organization, a telescope is your friend. You can look for moons, other planets, or stars just by sitting in your balcony or your backyard at home. Neat, huh? Stars. Stars are perhaps the most recognizable celestial bodies in space. Even without studying astronomy, most people would be able to identify what stars are. But stars are more than just sparkly things in the sky. They are made of plasma, the only one among the 4 fundamental states of matter that does not exist naturally on Earth. The reason why they shine and look pretty in the sky is because hydrogen and helium particles in the star's cores fuse together in extremely high temperatures, or what's simply called thermonuclear fusion. Stars form inside the dense, concentrated gases and dust scattered throughout galaxies. There are regions in space which have extremely cold temperatures, about -442 to -424 degrees Fahrenheit, or -263 to -253 degrees Celsius. Gas atoms bind together in these temperatures. The most common gases found in gas clouds are carbon monoxide and hydrogen gas. The coldness also causes gases to cluster to high densities. After reaching a certain point of density, stars form when the denser parts of the cores of gas clouds fall under their own weight or by gravity. The cores weigh 100,000 solar masses in the form of gas and dust. Because the cores are denser than the clouds, they collapse first. When the cores collapse, they break down into clumps about 0.1 piece or parsecs in size and 10 to 50 solar masses in mass. Twinkle, twinkle, little star, how I wonder how little you are. We may see stars as tiny silver dots from the ground, while in fact, stars are actually gigantic. They just appear small because they are a great distance away from Earth. The Sun, which we consider to be big, is the closest star to Earth and one of the smallest stars out in space. Stars also come in different colors that help detect how old a star is and how much longer will they last. There are blue, blue-white, white, white-yellow, yellow, orange, and red stars. This color order is from the highest temperature to the lowest. Blue stars are also the brightest and usually the youngest stars to exist. As they become older, they change colors, drop in temperatures, and lose luminosities and eventually turn into a cold dark matter. But that won't happen for a long time. Stars live for billions of years, possibly even longer. They are also classified according to their sizes. Stars are sorted as hypergiants, supergiants, bright giants, giants, subgiants, dwarfs, subdwarfs, and so on, also considering their colors and luminosities. The Sun is classified as a yellow dwarf. What makes stars more interesting? Constellations. Those are stars that are grouped together and form imaginary outlines and patterns of people, animals, or objects, usually associating mythological creatures and characters with them. Not all stars are a part of constellations, because no definitive star patterns can be formed in some areas in space. It's actually ancient people who thought of constellations. Stars don't really get to decide where they are going to be positioned, so these patterns are based from human creativity, trying to associate stars with their beliefs and culture. Animals in space. Did you know that the first beings from Earth that flew in space were not actually humans? Yes. Now let's take a look at the timeline of space exploration and the animals that have become part of it. The first animals from Earth that flew in space were actually fruit flies. In 1947, fruit flies were sent aboard the Nazi V-2 rocket, which flew around 108 kilometers or 67 miles away from the Earth. In 1949, Albert II became the first monkey in space when he reached an altitude of 134 kilometers or 83 miles. In 1950, a mouse was sent inside a rocket that flew around 137 kilometers or 85 miles before disintegration. The Soviet Union, on the other hand, used to fly stray dogs on suborbital flights. Laika the dog from the former Soviet Union is perhaps the most popular, as she became the first living being to orbit the Earth aboard Sputnik 2 in 1957. While in 1963, the French space program used Félicette the cat, making her the first cat in space. She flew at an altitude of 160 kilometers or 99 miles and was able to return to Earth safely. As of today, there are a total of 32 other monkeys who have flown to space, and there was even a turtle from the Chinese space program. And while you may think that sending animals to space is a novelty, they actually serve a greater purpose by providing scientists and astronomers valuable research and insights on the effects of space to living organisms, which in turn will make future space flights for humans and animals alike more safer. Moon. Quick, look at the night sky. What's the most striking celestial object at night? It's of course the moon. The moon is a natural satellite to our Earth, which means it's a natural occurring object that orbits around our planet because of gravity. There are of course other moons, which are natural occurring satellites to other planets as well. Some planets even have more than one moon, like Mars and Jupiter. But let's talk about our own moon. The moon takes its name from moon, which was derived from Monet, a developed form of Mona, which was the term used in the Old English language. Sometimes the moon is also referred to as Luna, especially with regard to other moons. Luna specifically refers to the Earth's moon. The word Luna itself was derived from the Latin term for moon. The Earth's moon has an orbital distance of 384,400 kilometers, or 238,855 miles, which is about 30 times the diameter of Earth. The moon has a solid iron-rich inner core, covered in a liquid iron outer core. Around the core is a partially molten mantle made of magma, then finally the crust. Researchers theorize that the Earth's moon may have formed 4.51 billion years ago, just slightly ahead after Earth's formation. The most widely accepted theory is that the moon was formed from the remaining space debris left by a giant impact between Earth and Theia, a large celestial body that is close in size to Mars. With regard to Earth's rotation, the moon is synchronous with it. This means that when viewed from Earth, the moon always appears on the same side or face. Next to the sun, the moon is the next brightest celestial object seen on Earth. But the moon actually does not give off light. It only appears bright at night because of the light that it reflects from the sun. The Moon has phases, as observed from Earth. This is because at different points in time, some of the Sun's light is partially blocked, so a shadow is cast on the Moon. This is why, from the Earth's perspective, the Moon may appear crescent, half, or full. Since ancient times, people have learned to study and track the phases of the Moon. This recording and tracking of the Moon forms the basis of early astronomy and is instrumental in many fields such as agriculture, fisheries, navigation, and is also a basis for early calendars. The Moon also is responsible for causing tides, as its close proximity to the Earth allows it to influence its own gravity on the Earth's waters. Solar flares. The Sun. A star that is at the very center of the solar system. It gives us warmth and light. But did you know that within it are countless physical and chemical processes that fuel the energy of the Sun? Observe this. That looks like a large explosion on the surface of the Sun. It almost looks like the flames of a wildfire. What you are looking at right now is what's known as a solar flare. Solar flares are sudden flashes of brightness that can be observed near the Sun's surface. And it's not just a light flash. Solar flares emit a wide variety of emissions, covering a very broad spectrum of energy. Let's take a look. The energy released in a solar flare is typically 1 × 10 to the 20th power joule. That's 1 followed by 20 zeros. For comparison, that amount of energy is millions of times stronger than a volcanic eruption. But that's just the typical solar flare. A major solar flare event can go up to 1 × 10 to the 25th power joules, roughly the equivalent of 1 billion megatons of TNT. Solar flares also eject clouds of particles in space, which includes ions and atoms. Sometimes, these clouds reach Earth after a day or two of the solar flare event. Solar flares also occurs in other stars, but the term used is stellar flares. So how does one occur? Solar flares occur when sped-up charged particles, mainly electrons, interact with the plasma of the Sun. The acceleration is caused by the phenomenon of magnetic reconnection. When this happens, a large amount of energy is released, which causes an eruption of energy emissions. How do these affect the Earth? Well, solar flares have great influence over local space weather near the vicinity of Earth. Solar flare emissions of energy also produce a solar wind that can impact the Earth's magnetosphere, which carries harmful radiation, especially to spacecraft and the astronauts in it. Stronger solar flares can sometimes cause a coronal mass ejection, or CME, which are known to cause massive interference and even disable radio satellites and power grids on Earth, causing blackouts. The influx of X-rays within solar flares can also cause the ionization of the atmosphere and interfere with short radio waves of Earth, causing signal breakdowns for Earth's local communication devices. Mars, the fourth planet from the Sun, now coming in with a diameter of 6,792 kilometers or 4,220 miles and a mass of 6.42 times 10 to the 24th power kilogram or 1.409 times 10 to the 24th power pounds, with two moons, namely Phobos and Deimos, and an orbit period of 687 days. Its surface temperature is a cold negative 153 degrees Celsius to a cool 20 degrees Celsius, or negative 243 degrees Fahrenheit to 68 degrees Fahrenheit. The second smallest planet in the solar system and known famously as the Red Planet. Welcome to Mars. Mars takes its name from the Roman god of war. The association with the god of war comes from the fact that Mars has a bloody red color, and it's not just the Greeks and Romans. Other ancient cultures also associate Mars with its redness. Ancient Chinese astronomers called Mars the fire star, while Egyptian priests simply referred to it as the Red One. Mars's redness is actually due to a large amount of iron in its soil. Despite its redness though, Mars is actually cold, being 228.5 million kilometers or 141.6 million miles away from the Sun. Its surface is rocky and full of canyons, craters, mountains, and all sorts of formations. Scientists describe Mars as dusty, and in fact, this dust covers all of Mars. Dust storms caused by the wind in Mars is very common throughout the year. But how do we know all of this about Mars? Well, humans have been sending probes and satellites to Mars for a long time now. It was in 1965 when Mariner 4, a NASA spacecraft, first passed by Mars. In 1976, NASA successfully landed Viking 1 and Viking 2, making it the first Earth spacecraft to land on the surface of Mars. We have since been regularly sending space missions to Mars to gather more information about our solar system neighbor. In a few years' time, sending manned space missions to Mars are the next steps being carefully planned by scientists at NASA. And who knows, maybe Earthlings will be visiting and even living on Mars in the future. Quasar. What's the brightest thing in space? The Sun perhaps? The Moon? Or maybe other stars? If you guessed any of these, well, you're almost right. But what if I told you that there are objects in outer space far more brighter than stars? They are known as quasars, short for quasi-stellar objects. Quasars are very distant objects which are powered by black holes that have a mass billions of times more than our own Sun. Quasars were first discovered during the 1930s by a physicist named Carl Jansky, who worked for Bell Telephone Industries. He discovered that there was static interference on phone lines crossing the Atlantic, and deduced that interference may have been coming as waves emitted by the Milky Way galaxy. In the 1950s, astronomers by now have been using radio telescopes, which pair radio signals and visuals while looking at the stars. During this time, however, scientists noticed that some objects observed did not match. They referred to these as quasi-stellar radio sources for lack of a better term because they did not know at the time what they were. It would take another few years before astronomers deduce that these objects were not stars, but are actually bodies that are created as a result of particles being accelerated at the speed of light. Recently, scientists suspect that these tiny bright glimmers from distant outer space are signals coming from galactic nuclei. Quasars come from supermassive black holes. A supermassive black hole is a black hole that has a mass billions of times more than the mass of the Sun. Although light cannot escape black holes, some signals are able to break free from its edges and are accelerated near the speed of light. Most of the quasars observed are found to be billions of light years away from Earth. Since they are very far away, the light that can be observed from Earth are actually from an earlier point in time of the universe. So the more we observe far-off quasars, the more we get insights into what outer space was like billions of years ago. Scientists theorize that our very own Milky Way galaxy may have been a host to a quasar from way back at an earlier point in time. Quasars emit lots of energies. This energy can exceed billions, even trillions of electron volts. In fact, this energy is stronger than the combined energy of all the stars in our galaxy. And they are 10 to 100,000 times brighter than any star in the Milky Way. Hubble. Did you know how scientists take pictures of space? Well, some of the best pictures of space from the last 20 years were taken with a special satellite. Enter the Hubble Space Telescope. The Hubble Space Telescope, or HST, is a man-made satellite space telescope that was launched into low Earth orbit in 1990. And it has been in operation since. Although not the first space telescope, the HST is one of the largest and most versatile. It is considered as a vital research tool for astronomy. The Hubble is equipped with 4 main instruments that is used to observe near ultraviolet, the visible, and the infrared spectra of light in space. Hubble's orbit is just above the Earth's atmosphere, thus freeing it from the distortion caused by Earth's dust clouds and pollution. This allows the Hubble to take high-resolution images with low background light. Let's take a look at a couple of images taken by the HST. The Hubble is named after American scientist Edwin Hubble, who in the 1920s operated the largest telescopes of the time at Mount Wilson Observatory in California. The Hubble initially weighed 10,886.217 kilograms or 24,000 pounds and has gained an additional 1,360.777 kilograms or 3,000 pounds because of additional hardware fitted up until 2009. It also has a length of 13.3 meters or 43 feet, which is about as long as a large school bus. It can be found at the low orbit of Earth with an altitude of 547 kilometers or 339 miles above the Earth. Since its launch in April 24, 1990, the Hubble has made more than 1.3 million observations, which helps scientists obtain data for over 14,000 published scientific papers. The Hubble does not travel anywhere else. Its only movement is around the suborbit of Earth. It moves at about 27,359 kilometers per hour or 17,000 miles per hour. The HST also has no thrusters. It moves by using the principle of the third law of motion. It has wheels that spin in the opposite direction that it's going. While the Hubble is near Earth, it has observed and taken pictures of places as far as 13.4 billion light-years away from Earth. And the whole of the Hubble archive can be summed to about 140 terabytes. Neil Armstrong. One small step for man, one giant leap for mankind. These were the immortal words that one Neil Armstrong quipped as he became the first person ever to walk on the moon as the commander of the Apollo 11 spacecraft. Neil Armstrong was born in Ohio on August 5th of 1930. He had his start as a naval aviator in the years of 1949 to 1952. In 1955, Armstrong joined the NACA, or the National Advisory Committee for Aeronautics, as an engineer and test pilot. As a side note, NACA eventually became NASA. Armstrong became a research pilot for many of NASA's developmental projects. He is also known to have flown over 200 types of aircrafts. In 1962, Armstrong officially became an astronaut. 4 years in, he successfully became the first person to perform docking for 2 vehicles in space. Finally, in 1969, he became the first person to step on the moon, following the successful launch of the Apollo 11 along with his team, fellow space pioneers Buzz Aldrin and Michael Collins. Armstrong's career at NASA continued after the Apollo 11 mission, as he became the Deputy Associate Administrator for Aeronautics of NASA. He also became a professor in the 1970s at the University of Cincinnati and was chairman of Computer Technologies for Aviation Incorporated in Charlottesville. Throughout his lifetime, Armstrong has received many academic awards and special honors, including countless honorary degrees from prestigious universities, a Presidential Medal of Freedom, and the Congressional Gold Medal, to name a few. Neil Armstrong passed away on August 25, 2012 at the age of 82, but is fondly remembered for his contribution to space exploration and research. Asteroids. What do you call the masses of space rocks floating in outer space that are smaller than planets and even smaller than our moon? These are called asteroids, the small airless rocky masses that also orbit the Sun. They are too small to be called planets. That's why sometimes asteroids are also referred to as planetoids or minor planets. But despite their relatively small size, asteroids can also be dangerous, posing as threats to our very own Earth. Imagine a large rock mass hitting the Earth with an increasing velocity. Actually, asteroids have hit the Earth in the past, but these were not big enough to pose a threat to Earth. Scientists, however, are still interested in studying them to learn about matter from space and also how to detect and be prepared in case a big enough asteroid hits Earth. So where do asteroids come from? Scientists believe that asteroids are the leftover debris from the formation of the solar system some 4.6 billion years ago. It is theorized that the formation of the giant planet Jupiter had prevented any other planetary body from forming in between its gap with Mars. This caused objects in space to collide with each other, and the resulting fragments are the asteroids that we see today. Asteroid sizes vary widely. For example, Ceres is 940 kilometers, or 584 miles across, while asteroid 2015 TC25 is just 2 meters wide, or 6.56 feet wide. Most asteroids have a very irregular shape, but there are some that are spherical like planets as well. Asteroids also have a cratered surface, which is the result of asteroids hitting each other in space. Like the planets of the solar system, asteroids also orbit around the Sun, as they are affected by its gravitational pull. Some scientists believe that it's also likely that the moons of other planets started out as asteroids before becoming permanently stuck in the orbits of their respective planets. The average temperature of an asteroid is a cold -73 degrees Celsius or -100 degrees Fahrenheit. Does the thought of asteroids hitting Earth scare you? Well, asteroids have been hitting Earth since its formation some 4.5 billion years ago. In our modern age, however, the asteroids that do hit Earth are very small and pose no immediate threat. But scientists think that if a big enough asteroid could hit Earth, it would cause global disaster, creating such a strong impact. The resulting debris may block out atmosphere and create a nuclear winter. Luckily, this type of asteroid is rare and estimated to only happen once in 1,000 centuries. Comets. So, we've just talked about asteroids, the large masses of rock that orbit our solar system. Now, let's look at comets. The most distinguishing feature of a comet is its tail. To compare, here's a comet with its tail, and here's an asteroid. So, what are comets anyway? A comet is an icy body in space that releases gas and dust. To illustrate this, think of a dirty snowball floating in space. Comets usually contain a mixture of dust, ice, carbon dioxide, ammonia, methane, and some other gases. Scientists think that comets may have been the leftovers from the gas, dust, and ice that initially formed during the birth of the solar system around 4.6 billion years ago. More so, some researchers think that comets may have been responsible for bringing water and organic molecules to the Earth when it was newly formed. Comets can be found at the farther region of our solar system, far beyond the orbit of Pluto, which was formerly considered a planet. This region is known as the Oort cloud. So, we've already established that comets are the dirty snowballs of space. The mass of ice, dust, and particles are known as the comet's nucleus. Now let's talk about the comet's tail. As a comet gets closer to the Sun, the ice on the surface of the comet turns into gas. This gas forms a cloud called the coma. The radiation from the Sun pushes this cloud away, thus forming a visible comet's tail. This radiation also converts some of the gas cloud particles into ions, which also forms a less visible ion tail. Since the tails are the result of solar radiation from the Sun, comets' tails always appear opposite the direction of the Sun. Comets are very similar to asteroids in appearance, so sometimes comets are misidentified as asteroids. That is, until closer inspection, when the observance of a tail and gas cloud confirms that it is indeed a comet. In older times, comets were often seen by the ancient peoples of the world to be omens of bad luck or doom. But of course, comets are a naturally occurring phenomenon. Historians from way back in ancient times have been observing and keeping record of comets for a long time now, which provides today's researchers with invaluable data. In general, comets are named after the people who discovered them, or in some cases, after the spacecraft that discovered them. One of the most popular comets is of course Halley's Comet, a potato-shaped comet roughly 15 kilometers or 9.3 miles long. Halley's Comet is visible to the Earth once every 76 years. The comet is named after 1600s English astronomer Edmund Halley. The comet was actually discovered and observed earlier and can be seen in different ancient records, like the Bayeux Tapestry of 1066, or even the records of ancient Chinese astronomers from 240 BC. Venus, the second planet from the Sun, now coming in with a diameter of 12,104 kilometers or 7,521 miles and a mass of 4.87 times 10 to the 24th power kilograms or 1.073 times 10 to the 25th power pounds, coming in with 0 moons and an orbit period of 225 days. Its surface temperature is a sizzling 462 degrees Celsius or 863 degrees Fahrenheit, which makes it the hottest planet in the solar system. It's the planet that's almost the size of our Earth. That's why it is often referred to as Earth's sister planet. Welcome to Venus. Compared to the Moon, Venus is the second most visible natural object in the Earth's sky. It has a magnitude of -3.8 to -4.6. This means that on a bright, clear day, Venus is visible on Earth. Venus is of course named after the Roman goddess of love and beauty. This might be because the ancient Babylonians thought that the planet Venus was the bright queen of the sky. In the Greek and Roman cultures, Venus was initially thought of as two distinct stars, namely the morning star and the evening star. This is because there is a point in the orbit of Venus where it overtakes the Earth, which makes Venus switch from being visible at daytime to nighttime. Researchers suggest that Venus may have once had a climate that is very similar to Earth billions of years ago. But the strong greenhouse effect in the planet may have caused all of its waters to boil and evaporate. Venus also has a peculiar rotation as it rotates clockwise, a trait that it shares with another planet, Uranus. Speaking of peculiar, Venus has no tilt in its axis, which means it has no seasons. A day in Venus is equivalent to 243 Earth days, although a year in Venus is oddly enough roughly 224 days only. It has a weak magnetic field, but it has a very strong atmospheric pressure, about 92 times stronger than Earth's. Meteor. We've been talking about giant space rocks and dirty space snowballs, literally objects that float beyond the sky. But what happens when these masses come crashing down from the sky? Today, let's talk about meteoroids, meteors, and meteorites. But first, let's take a look at some history. In the ancient times, many people thought that meteors were fireballs in the sky, a sign of impending doom, perhaps the wrath of gods. In some cultures, it was thought to signal something important or even grant wishes. Little was known about meteors up until the 19th century. Till the 18th and early 19th century, people believed that meteor showers were some sort of atmospheric or weather phenomenon. The word meteor even comes from the Greek word for atmospheric. It was around the 1800s when Professor Benjamin Silliman of Yale University first suggested that meteors may have an origin outside of our world. Astronomer Denison Olmsted studied the phenomenon extensively and concluded the same thing. So what are they exactly? First up are meteoroids. Meteoroids are small rock and/or metallic bodies in space. The biggest difference between meteoroids and asteroids are its size. Meteoroids are significantly smaller than asteroids. For comparison, the size of a meteoroid can be as small as a grain to as big as 1 meter or 3 feet wide. Any bigger than that, and that's already an asteroid, while anything that is smaller than a gram are considered as micrometeoroids, or space dust. Meteoroids are actually products of the fragments and debris produced by colliding comets and asteroids. Meteoroids can also come from the debris created by the collision of asteroids and comets to other bodies in orbit, such as moons. Now that we established what meteoroids are, let's talk about meteors. A meteor, on the other hand, is the term used to describe the hot glowing meteoroids, comets, or asteroids that enter the Earth's atmosphere at a fast speed. When the meteor comes in contact with the Earth's surface, it is then called a meteorite. Okay, let's summarize. Meteoroids are the fragments and space debris caused by the collision of asteroids, comets, and other bodies. When these space debris enters the Earth, they are known as meteors, and when they hit the surface, they are known as meteorites. Typically, meteors move in excess of 20 kilometers per second, or 12.42 miles per second, while entering the Earth's atmosphere. Meteors in the atmosphere go through aerodynamic heating. Highly pressurized air flowing through the meteor heats up the rocky masses to a high temperature. This phenomenon produces a glowing streak of light from the object, as well as the particles that fly off it. What people refer to as shooting stars and falling stars are actually meteors. They look like stars because they glow as they enter the Earth's atmosphere. Sometimes, shooting stars or meteors appear one after the other and originate from the same direction. This phenomenon is known as a meteor shower. Nebula. We've been talking about fragments and debris in space. Now, let's take a look at nebulas. The word nebula is taken from the Latin terms for cloud and fog. As you look at their appearance, it's easy to tell why. But nebulas are not clouds per se, as you would define clouds here on Earth. So what are they? Well, nebulas are an interstellar cloud consisting of gases and space dust. Nebulas can be considered as part of the ingredients and building blocks of stars. Scientists think that stars begin to form when a nebulous mass of dust, gas, and interstellar cosmic rays clump together and collapse on its own weight. As the nebulous mass converge, it gives off ultraviolet radiation as it becomes hotter and eventually ignites and becomes lit. A star is born. Let's take a look at some types of nebulas. The emission nebula, as the name suggests, is a type of nebula that emits intense heat and energy. The heat comes from newly formed stars that emit large amounts of heat and radiation. This type of nebula usually glows with a reddish-pinkish color, which is caused by the presence of hydrogen gas. An example of this type of nebula is the Orion Nebula. Reflection nebulas, on the other hand, are not as hot, but still give off a distinct glow. This happens when a nebula happens to sit in an area where the stars are not as hot. But nonetheless, this type of nebula gets its glowing appearance because it reflects the light of a nearby star. To illustrate, you can check out how dust particles are visible when they are exposed to a light source. This type of nebula is not as far and has a bluish glow. The blue color appears because of the phenomenon of light scattering. An example of this type of nebula is the Witch Head Nebula. And lastly, let's take a look at the Planetary Nebula. It is named like this because astronomers from the 18th century thought that these circular nebulas looked like planets when they first discovered them. Planetary nebula are formed when a star runs out of fuel and finally blows off an outer layer of gas in the shape of a bubble, much like how explosions look like underwater. Planetary nebulas are unique and are estimated to be visible for around 50,000 years before the space dust is diffused and mixed back into the space of its surroundings. An example of this type of nebula is the Ring Nebula. The space race. A race to space? Who would have thought? But that's exactly what happened in the period of the Cold War between the United States and the Soviet Union. Both global superpowers with extremely opposite systems of government and ideology. The Cold War is characterized as a period of general geopolitical tension post-World War II between US and its Western allies against the Soviet Eastern Bloc. While there were no large-scale wars, both factions ascribed to one-up the other by industrializing, enriching their economy, developing nuclear weapons, and yes, finding out who could reach space first. The year was 1955, and the race was on. Both countries had just announced plans to launch satellites into orbit. On October 4, 1957, Russia successfully launched the Sputnik 1 into orbit, effectively taking the early lead in the space race. The US would follow up with their own Explorer 1 4 months after. In April 12 of 1961, Russia again took the lead by sending cosmonaut Yuri Gagarin as the first person in space aboard the Vostok 1. In the same year, the US started plans to send the first person to the moon. This was backed by then US President Kennedy. In July of 1969, the US launched the Apollo 11 spacecraft with a crew of 3 astronauts: Neil Armstrong, Buzz Aldrin, and Michael Collins. The space race formally ended in 1975 when political tensions from each side simmered down, and both the US and Soviet space teams worked together on the Apollo-Soyuz project. While it may have started because of political tensions, the space race was instrumental in putting space and astronomy research front and center for the public. It also put governments together to work on putting interest and funding to scientific endeavors that affect all of humanity. Black holes. It's not just the stuff of science fiction. For years, the mysteries surrounding black holes have been tugging at scientists and researchers. But truthfully, we have barely begun to scratch the surface with what little we know. Generally, a black hole is described as a region in space and time that has such a strong gravitational pull. So strong, in fact, that nothing, not even light, radio waves, particles, and radiation can escape it. Because of this strong gravitational pull, scientists and the best of Earth's technology still cannot directly observe a black hole. So how are we able to observe it? Well, scientists indirectly observe the particles and radiation that are being drawn into the black hole. So where do black holes come from? Scientists theorize that black holes are formed when a star collapses in on itself. When this happens, the star's mass becomes densely packed, and this exerts a very strong gravitational pull. This strong gravitational pull then starts to attract nearby space objects like dust and other space particles, which contributes to the growing size of the black hole. Scientists have identified two layers of a black hole based on what can be observed here on Earth. The first layer is called the event horizon. This is the point in the black hole where light can no longer escape. Meanwhile, the second layer is called the singularity. The singularity is the point where all of the mass of a black hole is concentrated. Black holes come in a variety of sizes. The smallest type of black hole is called the primordial black hole. Scientists believe that this type of black hole is as small as a singular atom but has the mass of a big mountain. On the other hand, a stellar black hole is considered as the medium-sized black hole. Stellar black holes have a mass that can go as 20 times greater than the mass of the Sun. Many stellar black holes can be observed in the Milky Way galaxy. The largest black hole is called a supermassive black hole. These black holes have a mass that is larger than the mass of 1 million suns. Scientists think that each large galaxy has its own supermassive black hole in its center. The supermassive black hole of the Milky Way is known as the Sagittarius A. So, is the Earth and the solar system safe from the threat of a black hole? Currently, there are no known black holes observed in the solar system. Hypothetically, however, if the Sun would collapse on itself, the resulting black hole's gravitational pull would have to be greater than that of the Sun for it to be able to attract nearby objects in the solar system. Otherwise, the planets would just revolve in orbit around it. Olympus Mons. Today, let's talk about a particular landmass on the surface of Mars. Mountains, volcanoes, and other surface features are not just exclusive to Earth. Let's just say, if the Earth has Mount Everest, then let us introduce you to Mars's Olympus Mons. Olympus Mons is not really a mountain per se, but it is actually a very, very large shield volcano on the surface of Mars. It has a height of 22 kilometers or 13.6 miles. That's almost as tall as about 2.5 Mount Everests on top of each other at above sea level. Currently, it holds the record as the tallest mountain of all the planets in the solar system. Olympus Mons takes its name from the Latin form of Mount Olympus, or the mountain where the gods of Greek mythology lived. Scientists think that Olympus Mons is the youngest of the large volcanoes on the surface of Mars, formed sometime 3,700 million years ago, in the year scientists call the Hesperian period. A period in time on Mars characterized by widespread volcanic activity and catastrophic flooding. Olympus Mons can be found in the Tharsis Montes region of Mars. This region is roughly near the equator of Mars. Olympus Mons is one of the many volcanoes in the area. For comparison, Here's how big Olympus Mons is when compared to some popular land masses on Earth. It has a height of 22 kilometers or 13.67 miles. Meanwhile, back here on Earth, our tallest volcano, Mauna Loa in Hawaii, is only 10 kilometers or 6.2 miles high. Olympus area stretches across 624 kilometers or 387.87 miles, which is almost as big as the US state of Arizona. Olympus Mons is classified as a shield volcano. This type of volcano has a low slope, giving it a shield-like appearance. Shield-type volcanoes are the result of lava flowing down on the volcano's sides. At the summit of Olympus Mons is a depression that measures 85 kilometers or 52.8 miles wide. But how can such a tall volcano form on Mars but not on Earth? Well, scientists think that it has to do with the lower surface gravity on Mars, combined with the higher rates of constant volcanic eruptions in the surface of the planet. This allows the lava to pile up higher on Mars. Scientists also think that the limited tectonic plate movement in Mars also plays a role in the formation of such gigantic land masses. On Earth, the tectonic plates move underneath the crust, limiting the steady buildup of lava, while on Mars, the limited movement of its plates allow lava to steadily pile up on the same place, thus forming taller land masses, such as the Olympus Mons. Jupiter, the fifth planet from the Sun, coming in with a diameter of 142,984 kilometers or 88,846 miles and a mass of 1.90 times 10 to the 27th power kilogram or 4.184 times 10 to the 27th power pounds. With 67 moons, 4 rings, and an orbit period of 4,333 days, just a little shy of 12 years, with a temperature of approximately -148 degrees Celsius or -234 degrees Fahrenheit. It's a gigantic planet with a great red spot. Welcome to Jupiter. The planet is named after Jupiter, the Roman god of thunder, who is considered the king of the Roman gods. The Romans, however, were not the first to discover the planet. The ancient Babylonians were the first to write about Jupiter around 7th to 8th century BC. Because of its large size, other ancient cultures also named Jupiter, the planet after their ancient gods. We have the Greek Zeus, the Mesopotamian Marduk, and the Germanic Donar or Thor. The planet is known as a gas giant, which means that it is mainly composed of gases. Jupiter is made of layers of gases that are composed of various elements, among them ammonia, sulfur, and hydrogen. Its interior, however, is a different story. It is composed of compressed hydrogen gas, liquid metallic hydrogen, and a core that consists of ice, rock, and metals. One of the most striking features of Jupiter is the Great Red Spot, a visible red spot that is actually a huge storm that has been going on for almost 350 years. To date, there have been 8 man-made spacecrafts that has passed by Jupiter. These are Pioneer 10 and 11, Voyager 1 and 2, Galileo, Cassini, Ulysses, the New Horizons missions, and most recently Juno. International Space Station. Imagine nations coming together to create one of the greatest scientific marvels of the century. A habitable spacecraft in Earth's low orbit. Seems like a good theme for sci-fi, eh? Well, it does exist. Enter the International Space Station also known as the ISS. A product of the collaborative efforts of governments, scientists, and engineers from all over the world. The ISS is an artificial satellite that is also a livable space station situated in Earth's orbit. It was made by launching modular segments from Earth, which were then connected and assembled in space. The ISS is also the largest man-made body that is circling in Earth's low orbit at an altitude between 330 to 435 kilometers, or 205 to 270 miles. The International Space Station completes an approximate 15.5 orbits in one Earth day. It serves as a space observatory and a lab where astronauts and scientists can observe Earth at low orbit and perform various experiments in a low-gravity environment. It is also a place for astronauts to stay and train for longer missions in space. Aside from these, the space station also serves commercial, diplomatic, and other educational purposes as well. In the future, the space station may be used as a port or station for manned missions in space. The ISS is an international joint project between the space agencies of the following countries: United States NASA, Russia's Roscosmos, Japan's JAXA, Europe's ESA, and Canada's CSA. The ISS was first launched in 1998 aboard a Russian spacecraft. More pieces were then added, and the space station was ready to be used come November of 2000. The space station has been in use since. The space station also continuously receives new modules, supplies, and parts from Earth. Inside the space station is approximately the size of a 5-bedroom house. It has 2 bathrooms, a gym, and a large bay window, and it weighs in at about 1 million pounds, or 453,000 kilograms. The space station consists of many parts, which are called modules. Each module has its special function, such as life support, communication, navigation, living quarters, and others. Modules are connected to each other by nodes. The ISS is powered by solar arrays, which collect energy from the sun and turn this into electricity. Outside the space station are robotic arms that are used for a variety of tasks, such as builds, repairs, and even moving astronauts outside the space station. There are also airtight doors called airlocks. These function as entrance and exit points for the astronauts. And finally, the space station also has docking ports to dock and connect spacecraft to the space station. Cargo and crew are flown to the space station with the help of the Russian Soyuz spacecraft. Lightyear. Space. It's so vast that it defies our concepts of near and far. Imagine, for example, the Earth's moon, one of the closest astronomical bodies near our very own planet. You could say that it's near, but how near is near? That's 384,000 kilometers, or 238,855 miles on average. How far is that? Well, it's the distance of 30 Earths side by side. Now imagine Alpha Centauri, the nearest star system next to our own solar system. It's approximately 41.32 trillion kilometers, or 25.6 trillion miles away from Earth. Now that's far. So how do astronomers measure such great distances without having to write exceedingly long numbers? Well, here's one way of measuring astronomical distances called the light year. The light year is defined as the distance light travels in a year. So, if light travels at the speed of 299,792 kilometers per second, or 186,282 miles per second in a year's time, that amounts to a distance traveled of about 9 trillion kilometers, or 6 trillion miles. At first, it might be a little bit confusing to some because of the way Lightyear is named. It's important to take note that the light year is not a measure of time, but rather a measure of distance that so happens to be the distance that light travels in exactly a year's amount of time. The light year was first used by Friedrich Bessel in 1838. He used it in an article he wrote about the distance of the star 61 Cygni. At the time, the favored unit of measurement for astronomical distances was the astronomical unit, or AU. The AU was based on the radius of the Earth's orbit, which is 1.50 times 10 to the 8th power kilometer, or 92,955,807 miles. Using this measurement, the distance of 61 Cygni was calculated to be at 66,000 astronomical units, or 9.9 times 10 to the 13th power kilometer, or 6.13 times 10 to the 12th power miles. To illustrate how far that was, Friedrich added a little trivia for his readers. Light takes approximately 10.3 years to travel that distance. Friedrich refrained from using it much though, because the speed of light was yet to be a determined constant at the time. In 1951, however, a German by the name of Otto Uhle used the light year in his articles on astronomy. Today, the light year is used to express great distances between stars found in a general area. Modern astronomers, however, prefer to use the unit of measurement called parsecs, the distance where one astronomical unit subtends an angle of 1 arc second, or 648,000 over pi astronomical units. A parsec is roughly 3.26 light years and is used to measure distances outside of our solar system. Food in space. Now picture this. You are in space with zero gravity. Then suddenly, you feel hungry. It's a given if you're traveling far away, you will need to bring food with you. That being said, let's take a look at some considerations when taking food into space. It should be compact enough. It should have a long shelf life. It should be manageable at zero gravity. And of course, it does help if it tastes good. In 1962, astronaut John Glenn was the first human to ever eat food in space aboard the Friendship 7. Scientists weren't even sure at the time if digestion was possible in space at all. Space food of the 1960s was based on US Army survival rations. This consists of pureed beef and vegetables packed in aluminum tubes that look very much like toothpaste tubes. The next development in space food came with the Gemini space program of the mid-60s. This type of space food utilized freeze-drying, where Earth-prepared food is flash-frozen after cooking and then heated to remove moisture and water content. The food is then vacuum-sealed and packed. A water gun is used to prepare the food in space by adding in water content to the dried food. In the 1970s, the Skylab program utilized frozen food for consumption in space, since the Skylab did run on water, producing fuel cells. And guess what frozen food astronauts like the most? Same as here on Earth, it's ice cream. In modern times, there have been a variety of space food that astronauts take with them to space. This is due to advances in technology and the increasing international diversity of astronauts in space. The food ranges from kung pao chicken, espresso coffee, matcha, sushi, kimchi, goulash, beef, and a wide assortment of dried fruits and nuts. And that was another interstellar trip across the universe. Remember to join us next time for another mission to the cosmos and beyond. Only on Inside Outer Space.